While numerical problems are a cakewalk for some of you, others might have quite different favorite areas in physics. But here's a problem in physics that will certainly make you think. Here's the problem. A bear falls from a cliff 177.3 meters high and reaches the ground in 6 seconds. What is the color of the bear? Are you stumped at the question? Yes, I'm asking the color of the bear. And this is a physics question. And the answer is not red. Every time I have asked this question in class, some students have said red, as the bear would be hurt after falling through such a height. But we rule out that option and take it as a problem to solve using our knowledge of physics. Let us solve this interesting problem. Our Earth. Looking at this picture of the Earth taken from space, it appears as if the Earth is a sphere. But careful measurements show while the equatorial radius, RE, is 6,377.83 kilometers, the polar radius, RP, is 6,356.91 kilometers. Thus, you can see that the equatorial radius is greater by about 21 kilometers. In comparison to the total equatorial radius, 21 kilometers is only about 0.33%, which is very small and therefore is not noticeable, and the Earth looks practically spherical. This small difference has a small difference between the values of acceleration due to gravity on the surface of the Earth at the equator and the pole, both at the sea level. Now, we know acceleration due to gravity can be calculated using the relation G equal to capital G, capital M divided by r square. So, value of acceleration due to gravity at the sea level at the equator can be written as GE equal to GM by RE squared, and that at the pole can be written as GP is GM by RP square, where capital G is the universal gravitational constant and capital M is the mass of the Earth, while RE is the equatorial radius and RP is the polar radius, as we have mentioned before. Substituting these known values, we get the value of equatorial acceleration due to gravity at sea level as 9.79 meter per second squared, while at the pole, at the sea level, it is 9.85 meter per second squared. Now let us go back to the problem given. Let me read it out again. A bear falls from a cliff 177.3 meters high and reaches the ground in 6 seconds. What is the color of the bear? Do you have an idea now on solving it? Well, let's do this. Using the formula S equal to ut plus half at squared, you know what these symbols stand for, so just let's use it. We see that here u, the initial velocity, is 0 as the bear falls from the cliff. So the formula can be written as S equal to half at squared. Substituting the values of S and t from the problem and calculating the value of acceleration due to gravity, we get 177.3 equal to a into 6 squared by 2, and therefore a equal to 177.3 times 2 divided by 36, which gives you a result of 9.85 meter per second squared. This is the value of G at the poles. Therefore, the color of the bear must be white. Wasn't that interesting? Solving this problem surely opens up a whole new window into how to analyze problems and ultimately solve them. I leave you with another food for thought. You have been taught that energy cannot be created and it cannot be destroyed. It can only be transformed from one form to another or transferred from one body to another. So, here's the question. What happens to all the different forms of energy that a meteor has, which burns up completely on entering the Earth's atmosphere? Discuss this question with your friends and then confirm your answer with your teacher. Bye-bye then. See you again in another lesson.